Look at this video for the setup that I will be using in this. There is a link in the text for this video. Here I'm running the hfplus units with antenna signals, plus this reference I have at minus 118 dBm. We have a lot of interference here in the 1.2.0 firmware with the 1633 software, but I didn't see the corresponding interference in these other two. Is this intermodulation or is it image? I can test that by use of sticky tuning. I changed the frequency and I didn't see what I wanted to show because things come and go. Here you have a horizontal lane. That's when the LO is changing. And I go the other direction. Well, and you can see it disappears abruptly at some point when I'm stepping. So it's a bit hard to see like this. So I add a signal on the mirror image frequency. Here is the signal on the mirror frequency from a signal generator, and here is the reference signal. Well, I turn the mirror image down a little bit, like that, and then I do the sticky tuning. Oops. At that point the LO changed to frequency. And I go back and now it changes again. And you can see the interference that comes and goes when I am on one or the other LO frequency. So I have to wait for it to come back some here. And you can see this interference comes in and that goes out. So this is the mirror image problem, which has been completely solved in the recent library for the, what was it, 1672 version of hfplus. Signals occur on the mirror frequency all the time, and this certainly degrades performance on this old version significantly. And we see nothing of that here, or here, or here, of course. So I think this is enough testing now of this old version, and I will install the latest firmware in this unit. Now the software and the firmware is the same in all the three units. The software is 1672 and the firmware is upgraded from 1.7.0 or 1.2. Whatever, I don't remember, to 1.7.2, which is the latest today, September the 2nd, 2018. And they all look very much the same. Now I enable the AGC in one of the units. So here is AGC, here is manual control, and here is manual control and with the pre-selector. Now it's obvious with the AGC we have nonlinearity problems. Occasional the same problem here, but not to that extent. But now I increase by 10 dB. The AGC fixes that. We can still hear or see the desired signal here. This one is completely saturated, and this one isn't much affected at all. Means problems are caused by frequencies outside the range of the pre-selector. And I can turn up more signal like that. Well, that's too much also for the pre-selector, but not here. Means now the saturation is caused by signals within the range of the pre-selector. On the Perseus, I bring up the antenna signal by 10 dB from here. And we have this one saturated, but the Perseus doesn't see anything. But we have intermodulation here. That was caused by something within the passband of the pre-selector. And, well, I don't know about this. Yes, well, here you can see. And then we have them here, but not here. I give more signal. And then these two are dead. Here, if I switch the desired signal on and off, it's on, it's off, it's on. It's hard to see, but it is here, just in the noise. But the Perseus has heavy clipping. So the desired signal is not very visible here either. I switch it on and off. Off, on, off, on. So it's this one. So this is clearly too much signal for any radio I have. And I turn down by, let's say, 6 dB. To make the Perseus happy. It has some little problems. Here the noise floor is very high, but we can see the signal. It is here. And the unit with the pre-selector, sometimes it's pretty good. Sometimes it's not so good. Of course, the signal from the antenna varies all the time. Like you see now, there is something strong in the 7 megahertz range. The AGC can use a low threshold or a high threshold. So I click on that just to see what happened. I would have expected the opposite, that the high threshold would switch in the AGC at a later stage. Well, maybe it does, maybe that is better. I go for low threshold again. And then we see nothing, almost. And high threshold. So high threshold is much better. And at this point, the strongest interference is here. Well, you have it here in the Perseus also. Well, it was here. Here we have something. And of course the pre-selector solves several problems, but not all of them. When running into saturation, of course one could increase the HF attenuation like this. Well, here and I switch off the desired signal and I switch it on again. We don't see it at all. What we see is some distortion product. So I go here and switch the desired off and on. On, off, on, off. And we see here, on, off, on. What? I cannot get it here. I can switch off the HF preamp. It doesn't help. So I reduce the antenna signal 20 dB and then I switch off the desired signal. So now we know where it is, and it is very weak now with these settings. Preamp on, it becomes stronger, and then I can reduce here. This is the point where it is very hard to see. And then I put the antenna signals back. Like that, and then 20 dB, and it disappears completely. While looking here, off and on. So the AGC controls the gain circuits better than the manual control does when the signals are very strong. So this chip is very complicated, and as far as I have understood, it's not possible to control it well with the manual controls. But in certain circumstances the manual control is better, and in other circumstances the AGC is better. So it's up to the user to try what is best when listening under difficult circumstances. This is the unit with the pre-selector and a very strong antenna signal. And we can see the desired signal here reasonably well, sometimes very well, sometimes with similarly strong interference. On the perceives we have ADC clipping occasionally. When this one is good, we don't have it, but when it's not so good here, we have ADC clip here. And we have interference in the passband with peak amplitudes that are approaching the level of the desired signal. Fairly similar to what can be seen here. So, under these circumstances, 7 MHz at night with a 20 meter dipole. I mean, the dipole is for the 20 meter band. Well, this is heavily saturated sometimes, and we have difficulties, and at the same time not so much here. I will compare them better. And leave it running for a while. The problems come from different mechanisms because they do not occur simultaneously. Now this, well, I just leave it running for a little while. You can make your own judgment which one is better or worse. Well, I increased the antenna signal by 3 dB. And I switched the desired signal on and off. We can see it in the HF Plus, but not in the Perseus. It's on, off, on, heavily disturbed, not so strong, but it is there. And here the saturation makes it useless. So in the Perseus I would have to click on the 10 dB attenuator, and then I can see the desired signal approximately or even better as compared to the HF Plus. In both cases, attenuation at the antenna input is very desirable.